Hey fellas, so in 6.5, we're going to go through two new types of parallelograms, okay? These are actually the last two special types of parallelograms called a rhombus and obviously a square. A rhombus is the first one, okay? So first of all, both of these have all the properties of a parallelogram because they are parallelograms. They're also quadrilaterals, so they obviously have four sides, okay? But because they're parallelograms, you should already know about these, the 5 things we know about parallelograms, right? They've got opposite sides are parallel, opposite sides are congruent, opposite angles congruent, consecutive angles supplementary, and the diagonals bisect each other. So all those properties still exist. You can still use all those properties, and you're going to need to still use all those properties to solve these problems. Okay, now we're just going to add some things about these to give them a couple extra properties. Okay, so the first one is for a rhombus. Right, there's 3 things about a rhombus that you know besides that it's parallelogram. The first one is that the opposite sides are congruent, or not opposite sides, all sides are congruent. Okay, so all 4 sides of a rhombus are congruent. Okay, so all of them are congruent. Everything else is basically like a italicized or a tilted square. Okay, so you know that. All right, the second thing you know about a rhombus is the diagonals are perpendicular, so they run into each other at a right angle. So all 4 of those are right angles, which means all 4 of those little tiny triangles are right triangles, which is really helpful for us for solving a problem. They're also going to be isosceles triangles, okay, because the opposite sides are all the sides are congruent. Okay, and lastly, the diagonals bisect the opposite angles. Okay. So that means that these little angles are going to end up being congruent to each other. Okay, so you've got lots of congruent things in this case. Okay, so it's going to help us solve tons of problems. All right, a square is just both a rectangle and a rhombus. Okay, so when this has all the properties of a parallelogram, all the properties of a rectangle, and all the properties of a rhombus. Okay, so you know basically everything is true for a square. Okay, so let me show you a couple of examples. Alright, so for this one we're going to use that rhombus on the right. Alright, that's definitely a rhombus. It's not a square. Squares are pretty easy to deal with, so I don't think you guys need too many examples with those because you've been working with them for a long time. But for this rhombus, okay, if angle ABD is 60 degrees, so that's talking about this angle right here is 60 degrees, we want to find angle BDC. Well, because these opposite sides are parallel, right, you know that the alternate interior angles are going to be congruent. So angle BDC is going to be equal to angle ABD, so it's going to be 60 degrees as well. Okay, number 2 tells us that AE is 8 and it wants to find all of AC. Well, the diagonals bisect each other, so AE is going to be half of AC. So AC is just double that, which is 16. Okay, I'm going to come back to number 3 because number 3 is a Pythagorean theorem problem, so that would be something like a bonus, so you don't need to worry about it too much unless you want those types of problems, okay? And number 4, we've got angle CEB is this angle right here. We know that the diagonals are perpendicular to each other because it's a rhombus. Okay, so this is going to be a 90-degree angle or a right angle. And number 5, they give us angle CBD is 58. CBD, so that's this angle right here, is 58. They want us to find angle ACB. So ACB is going to be this angle right here. All right. So because we know these are all little right triangles, we know that those two are complementary, right? Angle CBD and angle ACB. So they add up 90 degrees. So if you do 90 minus 58, you're going to get ACB is 32, not good math by me, 32 degrees. All right, and number 6. Number 6, AE is 3x minus 1. So this little part right there is 3x minus 1. AC, the whole thing is 16. We're going to find x. So if the whole thing is 16, you know that it's cut in half, so that little part's going to be just 8, which gives me the equation 3x minus 1 equals 8. So 3x equals 9, and x equals 3. Now number 7, right, CDB is 6y. CDB, that's this angle right here. That's going to be 6y. right? And ACB is this angle up here. That's going to be 2y plus 10. Well, we know that the angles bisect each other, okay? So we know that ACB is the exact same thing as ACD. So this is also 2y plus 10, right? And we get this part is 6y, right? And it's a right angle, right? Which means that those two angles have to be complementary, but they add up with 90 to give you 180. So it gives us the equation 6y plus 2y plus 10 equals 90. So 8y equals 80 and y equals 10. Now lastly, if AD equals 2x plus 4, so that's AD, and CD equals 4x minus 4, find x, right? All these sides are congruent because it's a rhombus, so we get 4x minus 4 equals 2x plus 4, so 2x equals 8, and x equals 4. Alright, so we also have to do this stuff in the coordinate plane. Okay, so if you look at these conditions, right, this will help you out when trying to prove these things. You're obviously going to be using slope, midpoint, and distance formula to determine if these parallelograms are a rhombus, rectangle, or a square. There's one example right there. Okay, so what we're going to do is we're going to do the same for the other ones. Okay, so I've got them plotted for us to try to save you a little bit of time. But once you get this plotted, right, there's a bunch of different ways that you can do this. Okay, you got to think of any properties of the type that you're trying to prove and show why that's true or not true. Okay, so we know that these are all parallelograms, which is nice. So we just want to say, is it a rectangle, is it a rhombus, and then if it's both, then it's going to be also a square. Okay, so one way to test if it's a rectangle is going to be proving the opposite, or the diagonals are congruent to each other. Okay, so that's actually really easy to do on something like this. All right, it's really easy to do in this case because if you look at those, right, the diagonals, they're actually going to be vertical and horizontal. Okay, and vertical and horizontal lines are really easy to find the slope of and really easy to find the distance of because you don't have to use the formula, you just got to literally count. All right, so the distance of diagonal BD, that up and down one, is just 4. Right? Also, likewise, the distance of AC is also just 4. So there's not a whole lot of calculation here. Right? Because those diagonals are congruent to each other, we know it's definitely a rectangle. Alright, so that's good. Alright, but we also have to test to see if it's going to be a rhombus. Okay, so in order to test to see if it's going to be a rhombus, we need to find the slope of those diagonals because one of the properties of a rhombus is that the diagonals are perpendicular to each other. Right, you can kind of see right away here that they're perpendicular, but you have to actually show me. All right, so if you find the slope of BC, all right, the slope of any vertical line is undefined, right? Or you can plug it in the slope formula and find that, right? And the slope of AC, oops, sorry, that should be BD. All right, the slope of AC is the slope of any horizontal line is 0, right? And those two are perpendicular to each other. So because of that, this is also a rhombus. All right, and because it's both a rhombus and a rectangle, it's going to be finally a square. So all of them are true for the first problem. All right. Now number 3, it's very similar to this. Okay, very, very similar. But so I'm going to do the exact same process. All right, I'm going to look at the distances of the diagonals. Distance of BD. That vertical distance is 6. The horizontal distance, diagonal AC, is just 4. So not a rectangle. Okay, so it's definitely not a rectangle. All right, but if I find the slopes are going to be the exact same as above. BD is undefined. AC is 0. Those are perpendicular, so it's going to be a rhombus. All right, but since it's not a rectangle, it definitely can't be a square. And number 2, right, this one just looks like a rectangle, right? You look at this and you think rectangle once you have it plotted, and you have it plotted pretty well. Right, so you could do the diagonal stuff, that's fine. Right, or what you can do is actually find the lengths of the sides. Right, just do the distance formula. Okay, so for this one, what I'm going to do is I'm going to find the distance from A to B. Okay, so the distance of A to B is going to be 1 plus 4 is root 5. Okay, find that distance, use the distance formula. Alright, if I also find the distance from B to C, alright, that'll either tell me if it's a rhombus or not, because these would have to be congruent if so. Alright, from B to C, we've got 4 squared is 16, plus 2 squared is 20. Alright, that's square root of 20. Alright, those clearly aren't the same, so it's not a rhombus. Right, because those consecutive sides are not congruent. Right, but if you find the slope of those should be perpendicular to each other, and if they are, that's going to be a rectangle. Right, so the slope of AB is going to be up 2 over 1. Slope of BC looks like we're going down 2 to the right 4, right, which reduces to negative 1/2. That's good news. Right, those are perpendicular to each other. So if you check the other two, the slope of CD, right, also 2, and the slope of AD comes out to negative 1/2. So since those are all perpendicular to each other, it is a rectangle, because rectangles have 4 right angles, right? And this last one, right, you can check. This again looks very much like a rectangle, right, but you need to obviously check with whatever those methods you want, right, to show that it actually is the case, right? And that's it.